For today, we're going to start looking for factors. Factors are basically things that multiply, give us a product. So, an example, factors of 12 are 6 and 2. Those are not the only factors of 12, but those are at least factors of 12. I have a list that helps you find out what the factors are. We're going to go a little more over this list in the classroom, but this list helps you find out what factors are of each number. So, an example, for example A, it says find the greatest common factor for each list of numbers. I'm going to start by finding the factors of 30. I'm just going to say 1 times 30, 2 times 15, 3 times 10, 5 times 6. Notice that my list on the left keeps on increasing. After 5, it's 6, which is already a factored. So all those numbers are factors of 30. Now for 45, I'm going to have 1 times 45, 3 times 15, and 5 times 9. Now, greatest obviously means the biggest. Common factor means that it's a factor on all the list. So looking at example 8, the biggest number that is in both lists, in this case, happens to be 15. For example B, my factors of 72 are going to be 1 times 72, 2 times 36, 3 times 24, 4 times 18, 6 times 12, and 8 times 9. For 120, I'm going to have 1 times 120, 2 times 60, 3 times 40, 4 times 30, 5 times 24, 6 times 20, 8 times 15, and 10 times 12. Once again, my list on the left kept on increasing. Now for 432, I'm going to go 1 times 432, 2 times 216, 3 times 144, 4 times 108, 6 times 72, 8 times 54, 9 times 48, 12 times 36, 16 times 27, and 18 times 24. Now, when I start looking, the biggest number that I seem to find is 24. There's nothing else that is in all of the list. So my greatest common factor in this case is 24. Now, for something like example C, I'm going to start with 1 times 10 and 2 times 5. For 11, I just have 1 times 11. And for 14, I have 1 times 14 and 2 times 7. The biggest number that I see in all of them happens to be 1. So find the greatest common factor for each list of terms. Now we're going to start looking at letters, but first of all, I'm going to start looking at numbers. I think we're good to go without making the list. Do the list that we just did in the previous slide if you need to. I'm going to say the biggest number that it's a factor for all four of these numbers will have to be 3. That's our greatest common factor numerically. Now, when it comes to letters, I have m to the 7, m to the 6, m to the 8, and m to the 5. We're always going to use the smallest factor. So for letters, it's easy, is the smallest exponent. Now, for B, I have no numbers. Now, when it comes to x's, I see these 3 terms have an x, but not the last one. So there's no x term because it has to be in all of them. Now, when it comes to y, the smallest exponent that I see is y to the second. Now here, to factor out the greatest common factor, on example A, I see that my greatest common factor is 5y. So I'm going to do the distributive property backwards. I'm going to open parentheses. Let me divide each of these by 5y. Looking at the first one, 5 divided by 5 is 1. And then on my exponents, I subtract them. So I get 1y to the 1. There's my plus. Then on my second fraction, 10 divided by 5 is 2. My y's cancel out. So example B, my greatest common factor, I'm going to say it has to be 5m to the third. On open parentheses, let me divide each of these by 5m to the third. My first one, 20 divided by 5 gives me 4. Subtract the exponents. Then there's my plus sign. 10 divided by 5 gives me 2. Subtract the exponents. And then lastly, 15 divided by 5 gives me 3. Subtract the exponents. There's no more m. Now, in this case, it's basically the same thing, but I see my first number is a negative, so I'm going to factor out a negative value. Let me factor a negative 7a. I'm going to open parentheses. Let me divide everything by a negative 7a. So in my first one, negative 14 divided by negative 7, that's positive 2. A to the second. Remember, I subtract my exponents. Negative 21 divided by negative 7, that's a positive 3. A to the 1. And then lastly, positive 7 divided by negative 7, I get negative 1. There's no more a's because they cancel out. Remember, on exponents, I subtract the exponents. Now here, this whole thing is a term. This whole thing is a term. So I'm going to factor out an a plus 3. If I was to divide both of these by a plus 3, I see that cancels out. So I get a, that cancels out. I get plus 4. Same thing I'm going to do for my example B. I'm going to factor an x plus 1. If I divide both of these by x plus 1, this cancels out. So I have x squared minus 5. This is something we're going to get to a little more in depth later. Just one thing I want to emphasize is the order of the factors does not matter. For example B, we have that answer, but if you guys go x squared minus 5 and then x plus 1, then that's the same thing, right? The order of the factors does not matter. Now here, factor by grouping, every time we have 4 terms, we're going to do factor by grouping. I'm going to be looking at the first 2 terms only. The greatest common factor of that one is 2. So I'm going to factor out a 2, divide each by 2, and you should get x plus 3. Now, on my last 2 terms, let me factor out a positive a out. That's my greatest common factor. Divide each of these by a, and you should have x plus 3. Now, it looks like a previous slide. I'm going to factor an x plus 3 out of each, and I'm going to have 2 plus a. Same thing I'm going to do for example B. On my first 2 terms, let me factor a 6x out. Divide each of those 2 terms by 6x, and we're going to have a plus 4. Looking at the last 2 terms, let me factor a 1. Let me divide both by 1, and I have a plus 4. I have to factor something. So my factorization will end up with a plus 4 and 6x plus 1. Now these are a little interesting. Let me rearrange things. I'm going to go 10x squared plus 15x. I want those that have x's together. Then I'm going to go minus 8xy minus 12y. Okay. I'll talk about a little why we organize it this way. I'll talk about it in class. So looking at the first 2 terms, I'm going to factor out a 5x out of each. So we're going to have with 2x plus 3. On the last 2 terms, let me factor out a negative 4y out of each. And I'm going to have 2x plus 3. So my factoring should end up being 2x plus 3, 5x minus 4y. Same thing with my last example. I'm going to have, let me do 2xy minus 8x minus 3y plus 12. Once again, I'll talk a little bit of this in class. On my first 2 terms, I'm going to factor a 2x out. So I'm going to have y minus 4. On the other 2, let me factor a